Hello, Ricky. How are you?
Hello.
Hello, Ricky. How are you? Hello, Alex.
How's it going? Nice to meet you.
Nice to
Finally
meet
well, not in person, but over call.
you. Nice to meet you all. Can you give us like 5 minutes so we can start?
Sounds good.
Yeah. السلام عليكم. ازيكم يا شباب؟ اهلا بيكم في اليوم الخامس في الكوانتم سامر سكول، الكسندريا كوانتم سامر سكول. النهارده ان شاء الله معانا شركة كيو بريد. هيشرحوا لنا النهارده البلاتفورم بتاعت كيو بريد والفكرة ورا البلاتفورم. Hello, Ricky. Hello, Alex. Welcome to our Alexandria Quantum Summer School. And we are very interesting to hear from you about the qBraid platform. So you can start.
Thank you, Mohammed. Marhaban and shukran. Thank you very much.
That's very sweet. Thank you. أهلا وسهلا. أهلا بيك.
That's the only few words I know, so I apologize, but the rest will be in English.
Yeah. That's very great. Yeah, thank you. You can continue in English. Yeah.
Okay, that's great. If anyone has any questions, please feel free to chime in though. Today I will be presenting on behalf of Harsha, who's out sick, but hopefully he'll get better. And then Alex will be there in person to also support the hackathon as well. So first and foremost, who has used qBraid before? Would anyone be able to just kind of raise their hands like I have so in the chat? The dean has, Ahmed has, and one more person. Oh, wow, we get numbers here. This is awesome. So 7, 8. Wow, okay. This is great. Awesome, awesome. So that is wonderful to see. You can put your hands back down. I just realized that. Okay, yeah, perfect. So that's a good number of people who've used qBraid. Alex, once you're there, maybe you can figure out how they've gone to use it and their experience and how we can make it better. But for those of you who have used it, this might be a little bit of a review, but today we're just going to go over how to use qBraid for the hackathon, the access code that you'll want to use, as well as the specific environments that might be relevant for you to try out today. All right, for the hackathon. Okay, so I'm going to first just share my screen. Let's see. You guys should see like the meeting itself, hopefully. All right.
Yeah, you're good, Ricky.
Perfect. Thanks, Alex. So I'm just going to go ahead and get started with the presentation here, which credit goes to Harshit for making. So this is with the hackathon with Alexandria Quantum Hackathon in Egypt. And first and foremost, we're going to just show how to get started, the SDK and VS Code. So in qBraid, we have basically 3 main steps that we want to achieve with all of our users, which is 1, you get started with lab, with just getting started with various quantum software. If you want to start using hardware, you use our SDK. Then our runtime, which is our backend service, allows to manage those jobs effectively. And our mission is to be your one-stop quantum computing platform. So what this means is that hopefully you'll do your development here in your hackathon and your ideas are good enough and you will take it to the next step on qBraid, use VS Code, run jobs, and so on and so forth, and support your journey as well as Egypt's journey in quantum applications in software. So as I mentioned before, we have kind of 3 main pillars. We'll start off with Jupyter, which I will show today, which is our comprehensive Jupyter Lab browser IDE. I think, there you go. So it's going to kind of bob up and down here, but we'll try and use this today. And then you will see that you can actually launch notebooks using the Launch on qBraid button as well. So all you'll have to do is open a public repo, code it on lab, and then submit your quantum circuits using the qBraid SDK. All right, so I'm going to just do a quick demo. Was that speed good enough? I know there are a lot of animations, so I'm just kind of curious. Was that okay? Was it visible? Latency all right? Okay.
Yeah.
Cool. Okay, so first and foremost, I'm going to drop in a few links here. So one, you'll need to create an account at account.qbraid.com, and you'll also want this code. I'm also going to give you another code as well. I think it's Hackathon 2025. Let me make sure these codes are correct. So when you get to account.qbraid.com, you'll be greeted by this kind of page after you log in. And if you click here and you just submit the code, they should probably tell you. All right, great. So it'll give you the correct permissions for using GPUs, as well as giving you a whole bunch of credits to run on various devices on qBraid. So what are the quantum devices that are available to you? Well, just a caveat, quantum computers can be quite finicky. Sometimes they are under maintenance. Some days they have a lot of new updates that essentially require some fiddling around with the version and packaging. And so if you have any of those issues, talk to Harshit, talk to Alex as well on during the hackathon. But in general, qBraid, we try and host the most quantum computers available in the world. You can see some of them that are available here as well. So what's really awesome about this is you have everything from simulators, such as SV1, to trapped ion quantum computers from IonQ, superconducting qubits, annealers. Well, this one's not quite available right now, as well as a whole bunch of other devices here. Not all of them on this list are necessarily available for this hackathon, but if you ask, we can try our best to give access. For this hackathon, you'll specifically be using IBM, if I recall, and Qiskit. So without further ado, we'll also show the quantum devices that quantum jobs you'll have available. And we also have like a nice composer if you ever need to just kind of drag and drop and build circuits as well. So, all right. So just to reiterate, come to your manage button and then just add it in your access codes here, and that will allow you to submit your access codes. And then once you've done so, you can come to this page and use the launch on qBraid button to launch your instance here. Any questions so far? If so, just please shout it out, as I'm on a separate tab and can't quite see text messages or DMs. All right, so one more. So while that's loading, and mine's loaded, but I'd also like to just show you another feature that we have is we have a bunch of awesome notebooks and examples here in the qBraid lab demo, which I'll also drop a link to here. And what's great about this is you can actually drop all of these links and just click on this launch on qBraid button. And there you go, you're ready to launch, and your repository will be cloned into your account. We have these links all over GitHub. So if you're interested, for example, in using NVIDIA, you can actually just come here and just go to the, I think the setup page, which is, aha, there we go. So you'll just be able to find NVIDIA CUDA Quantum as well here as well for you to try out. So I'll also drop that link if you're interested, since this hackathon does potentially use GPUs, and you can try out those here with this link as well to use CUDA Quantum alongside Qiskit, for example. The next time you can just click on these buttons to like just start to learn about how to use it as well. Okay, so without further ado, looks like my launchers have all been launched. So you'll see that each of these Jupyter Lab pages will open up to perhaps like the specific repository you want to work in. So in this case, I'm going to open up the qBraid Lab demo, and you'll see it right here. You'll see it. And I will also just, for this demo, use a separate notebook that Harshit made here, which is called the Using the qBraid SDK Demo Notebook. And I'm just going to get started with running it. But first and foremost, I want to tell you about our kernel features and our environment manager and what those all mean. So if you first come to qBraid and you're like, hey, I want to just get started, you'll get greeted with this default kernel, which has no packages installed, which is why you get this no module named qBraid. Of course, you can always just pip install here using the % symbol, and you can pip install. Another convenient way of using it, qBraid, is to use our managed environments, which you can find on the right here. Anything, and you can install. And what's really beautiful about it is we have various versions of Qiskit, as well as Penny Lane, which are, I think, the two of them that your team are most interested in using, as well as GPU compatible environments. So currently I'm not running a GPU, but when you do use a GPU, you'll be able to use this PennyLane GPU environment and run your circuits in an accelerated fashion. All right, so to install these, you just simply click on install. But I've already installed this qBraid SDK environment. So you can come here and just click on qBraid here. And this is my qBraid SDK environment. I see it switch over. It's disconnected. It should connect soon. And once it's connected, you can confirm at the bottom here. It says idle. A little hard to see, sorry. Idle here, and you can also see this and confirm the status of your kernel. So the difference between these is a kernel is the executor of each code cell here, and the environment is the conda or PyEnv environment, whichever you like, that qBraid, the packages are stored and can be installed into your qBraid account. There you go. Now I'm able to import qBraid without too much of a hassle. And I'm able to import the qBraid provider. If you've used Qiskit, if you've used Brocket, you're probably familiar with this provider class. This is basically a function that allows you to access various devices that are available to you. And in doing so, you'll be able to get all the devices, and we will run a circuit on the state vector simulator, which is the cheapest one. You can always check the cost of your devices here. You can check here. Oh, okay, so it's a per minute based pricing, and it costs around 7.5 credits per minute. Awesome. And then you also have the tensor network simulator, so on and so forth. Yeah. All right. Let me restart this kernel because it looks like it's taking a really long time. So I'm just going to restart it. Sometimes this does happen, but all good. And then you'll be able to get your devices that are available to you, then submit to the SV1 device. And we're just going to simply run one of the most important circuits and most simple circuits in quantum computing, which is just like the Bell state, which you can simply submit using circ, for example, write the circuit, and submit it to an AWS device. The beauty of this is you can write it in circ, you can write it in Qiskit, you can even write it in various other languages that are available on qBraid. You can view those in the qBraid lab demo, and you can even run it on real hardware. So what's nice is you have that write once and submit functionality. So it looks like this executed, so I'm just going to go through the rest of these cells and just show you. Okay, I have a ton of devices available. I'm going to pick the AWS SV1. The target spec is Brocket, which is the Amazon Brocket language. But you can use Qiskit, circ, whatever you like here to submit it. I need to install circ. So in doing so, you can install the necessary dependencies that you're interested in that are associated with qBraid. So there you go. And pip install them. They should all run. All right, maybe I should have done a quiet output here, but that's okay. And in doing so, you'll be able to write your maximally entangled Bell circuit as well. For IBM devices, you will still need to have an IBM API key, which you can still use through qBraid as well. It's been done through Qiskit Global Summer School. You'll simply just need to have your account and your access as well. All right. Uh-oh. If this ever happens and your disk queue just goes up, you can just simply remove like an environment that you've installed. So I'm just going to uninstall this. And that should probably be good enough. This is just a warning that you've used too much RAM within the plan that you have on qBraid. Let me just remove a few more things just for good measure. All right. Perfect. Okay. So it looks like the pip install all worked and the circuit was also able to be executed. So, oh, never mind. Just go ahead and do that. I'm going to uncomment this. Run the pip install. There you go. The bell circuit was executed or developed, and you can simply run this on the AWS device. Let me just do that again. Oh, okay. The kernel restarted. Okay. All right. Okay. So as you can tell, my kernel spec is all set. My program spec is all good. And so when I submit my job to the AWS simulator, I should find it showing up on my job extension here. Voila, I have it running here. I can even check like the circuit that was submitted. And there you go. I'm going to get my job back, and I'll be able to just get the results back for the job as well. For a simulator, it doesn't take a long time, but for some quantum devices, they have a long queue, and you just need to make sure you're well prepared for that just in case. All right, so it will take a tiny bit of time for it to come back with my job results. Let's see if my job is still initializing. It should be executing, hopefully. All right, it's been queued. That's awesome. All right, it should execute in the next minute or two. Let's see. And to submit your quantum circuits, again, as I mentioned before, you can just do that simply on Qiskit as well. Looks like it's now in the initializing state, which is awesome. That means it's going to get executed very soon. Oh, initialized, queued. Oh, looks like this job was completed. And there we go. We got our results back from the simulator. And it looks like we were able to show this maximally entangled state. Because it's a state vector simulator, you're going to get perfect results. On a quantum computer, you may get more varied results. And there you go. You can get your jobs back, and then you can even submit it to various quantum computers as well as done here. And you can submit a Qiskit circuit to a Rigetti device, for example. All right. If you're ever like, hey, I want to use a different computer, you can actually just come here and you can use the compute manager and say, hey, I want to start using like an H100, for example. Just make sure that you're aware that you are going to be chewing through credits. So those credits are available on your top left here, that you want to make sure that you are spending within the limits that you have available to you. So just make sure to do that as well. All right. Other than that, I can kind of go over the VS Code portion as well. And yes, Mohammed, you did ask about Penny Lane, so I'll just give you an example of how to use Penny Lane. So for example, you can do a few things with Penny Lane. So let me actually show a demo of this as well. We had that pip install example, so let me just pip install qBraid Penny Lane. So there are a few ways of using Penny Lane with qBraid. So you can actually use Penny Lane with the environment, which is not related to the qBraid SDK. You can just install this, and it will have Penny Lane available for you. There you go. We have different versions of it available. So 0.27, 0.34, I think there's 0.43 as well. Then there's also Penny Lane through qBraid SDK. So import Penny Lane. Oh, looks like there's an AutoGrad issue. Okay. Looks like there is a small issue with NumPy, but let me see if I can resolve that. Okay, I'm not quite familiar if this is an issue probably with the dependency chart. So I'm just going to go ahead and just install this Penny Lane package just to show what you can do with qBraid with it. All right. Talia, do you have a question? Or Dahlia, do you have a question?
Yes.
Yeah, what's up?
I used to work with qBraid during the Cascade Summer School, but I had an issue during running the cells. It keeps asking for starting the kernel. But what's the problem with that? يعني, I had to rerun all the cells and it took a lot of time. So how can I prevent restarting the kernel all over again?
I see. If you had an issue with your kernel restarting, you probably had unstable internet connection. But was that potentially the case here or no?
I guess not, because when I transferred to another environment, يعني say for running the cells, it worked.
I see. So if ever like the restart kernel shows up, just refresh your page, for example, and it should fix itself. Did you try that by any chance?
I mean, when I restarted the page, I had to rerun the cells from the start to be able to like import the libraries or anything.
I see.
It took time. I don't know if
Okay.
was an issue with my usage for the qBraid.
And this was for the KISS Global Summer School, is that correct?
Yes.
Okay, I think that should be fixed, or at least it shouldn't be an issue on this instance. So that was probably an instance issue where if you were to use like this KISS Global Summer School environment, we had some limitations for each user's server.
Okay, so like it had a certain period of working, and I have to restart.
Yes, so that should not be the case here. It should work the whole.
Okay, thank you.
Yep.
So
Yes.
this is the case for our hackathon
Mhm.
also. So this will be the case for our hackathon, and the kernel will be dead after some fixed period, also as the same as was in this Cascade Summer School. This was an issue.
Yeah, so it shouldn't be an issue anymore. Again, so let me just clarify. That's a good point. So let me share my screen again. So here you go. This is the Qiskit Global Summer School instance, which is like a separate cluster that we worked off of, which had some known limitations per user that we had. But with this main one called the default workspace, you should be okay. Does that make sense?
So we will work on the default during the hackathon?
Yep. Yeah.
Using the free instance.
Yes, correct. So as long as you don't run anything that's larger than the 2 virtual CPU and 4 gigs of RAM, you should be fine. If you need more, you can always upgrade. We are giving you guys credits to run on GPUs as well.
Okay, and the kernel will continue to work all the period we want.
The kernel should work the whole time, but if you have any issues, you should just let Alex or Harshit know. In general, I don't think there should be any issues with it, but if you do, it could be because you're trying to run something that is way too much, that takes up way too much RAM, but that would just kind of shut down your kernel. And in doing so, you should probably just try and use like a larger instance in that case, which you can't do with the GPU credits.
Okay, and also it depends on the internet connection. If I close close my tab or close my account.
Yeah, so if you
Some-
close your tab, then your execution won't work anymore. You have to keep your tab at least open.
should I keep the connection, the internet connection also stable?
Yes, that would be preferred as well. Yes.
Maybe this is an issue also because we need to move. Maybe we can shut down our execution and also go to sleep. Come the second day to run.
Ah, I see. Yes, if that's the case, then what I would also recommend is to also try the VS Code version of qBraid as well, which will help you make sure that that is either run locally, so it runs, through the night as well. So let me kind of show you that. All right. So let me just reshare my screen here. Okay. So this is just my VS Code that's running locally. And you can actually have like your own environment manager set up as well as compute manager. I don't have it set up right now, but what you can do is you can use this to basically use qBraid locally, submit your jobs, for example, and use it with IBM. I would recommend probably using this in this case if you're interested, where you can then create your own environments and have it run for as long as you would need, as long as it's developed locally. Does that make sense?
Okay, thank you for clarification.
Mhm.
Okay.
Sorry, how did you merge the qBraid with the VS Code again?
Yeah, that's a great question. Sorry, I know this is kind of brushing over things. But you can just search up Quantum Console here, and it'll show up.
Okay.
So like the qBraid extension.
Okay.
Yeah.
Okay, thanks.
And you could also use the environment manager as well here, which you can install. And this will allow you to activate certain environments, as we mentioned earlier, for you to run.
And this will automatically connect my qBraid environment with VS Code, right?
Yes, that's correct. So this is where we have like cloud environments. I don't have it set up here, but you can use it, your cloud environments available to you. All you need to do is just come to your API key, copy it, and then make sure that it's set up here. So,
Okay.
yep. So yeah, those are probably your best options for running it through the night. Those are excellent questions. Thank you so much. That was very helpful. We do not have IntelliJ set up, but that might be something that we want to work on. Yeah.
Okay, thanks Rick. Thanks Alex. في أي حد عنده أسئلة أو محتاج يسأل على حاجة؟ feel free to ask.
Okay, so I'm also kind of reading Ahmed's suggestion. So apologize for my inability to use Penny Lane. It's been a while, but I did kind of go off of that suggestion, and you can just import pennylane.numpy, import pennylane as ML, and then I don't quite remember how to make a quantum circuit with Pennylane, so let me just go find out. Demo. All right, so this is a simple QML function for running a circuit here. So there you go. And it will return this. You can use from qBraid the transpiler. So first I'm going to just make sure to get the conversion graph. Oh. And I'm going to do from qBraid import transpile blur, I think. Conversion graph. Okay, this does not.
You have two H's, Ricky.
Thanks. Yeah. All right, there you go. So we have Penny Lane to Chasm 2, and then you can transpile it to other ones. So I'm going to use a transpiler. I'm going to convert it into a Qiskit Qiskit circuits from QML equals. So the QML circuit equals my quantum function. I need to pass in the number of qubits that I want as well. So I'm going to do 2 and 2 here. And then transpiler, I believe all you need to do is just do QML circuit, comma, Qiskit. Okay, give me 1 second. I think it's just a transpile function. Okay. Okay, so we cannot do measurements here, so we will just return the polyz function here. Okay, let's return. Okay, give me 1 second. I think this should work, but let me just. Okay, this is not quite the same, but let me just apply the Z circuit here. Okay. Z gate. Okay, let's try and transpile it to Chasm 2 first. All right, I tried to do it. I will take a tiny bit and I'll send a more robust demo in a bit. But yeah, you should be able to convert your Penny Lane circuit into other functions as well. This is on me for not quite knowing off the top of my head how to do this, but it should work. So let me make sure that. Okay.
It's okay. You can take it.
Yeah, I'll send the notebook after, and then it should probably work.
So in this part, you can convert any Qiskit code to or a Penny Lane code to Qiskit.
Yeah, the point is that you'll be able to convert it to other functions as well, or other Pythonic frameworks that are available on qBraid, such as Qiskit or Broadcat, etc.
Okay, that's very. So, hey, anyone have any questions?
Oh, actually, no. I think I know this.
There is equipment that can integrate it with the Colab as well as VS Code.
Yeah, you can certainly use the notebooks on Colab, but I don't think you can use the kernels on Colab. So that is a point to consider as well. Any other questions?
Actually, I was wondering about the GPU specs used in the qBraid. Can we have like a quick view of the GPUs?
Do you mean like can you kind of clarify what the question was?
What the type of the GPU working in qBraid?
I see. Yeah, that's a good question. So with respect to the GPUs that are available on qBraid, we have a whole bunch now that are through Lambda Labs. So you can just come to your compute and you'll find after you add the GPU for quantum code, you'll have H100s, A100s, a ton of the A100s, B100s as well. So, and you can see if whether it has capacity or not for your job, even in an A10. I'm almost there with writing the circuit. I think I was just being a little foolish here. But let me see.
Yeah, that's very powerful GPUs, I think. So, anyone have any question? تفضل يا شيمي. Go ahead.
Okay, as I understood, qBraid is just like an environment that has many kernels, cascade circ, etc. So in our problem, we will implement the solution in Cascade as an example. Why not use Cascade Direct and Jupyter rather than qBraid is hassle?
Yeah, you can use Qiskit directly, and then, for example, if you need to submit it to an AWS device, you can just use qBraid.
Okay.
And actually, qBraid providing more CPU power and GPU power than maybe your local machine. That's actually the main goal.
Yep. Also do that as well with GPUs.
So anyone have any questions؟ حد عنده أسئلة عايز يسأل أي حاجة؟ Okay, I think no.
I do have a question, if I can talk.
Yeah, sure. Yeah, go ahead.
Go for it.
Okay, so hi everyone. I might be a little bit late to the meeting, so you might have answered this question before, but my question is basically like, if there is any limitations to the platform, and also like, is it for free these days, or how is it exactly? Like, what are the limitations do we have, and what are the pricings and all of that?
Yeah, great question. And I actually just figured out how to get the circuit to run, so I can also show that. So for this hackathon, you can assume that whatever you have available to you is supposed to be free. And if you need more credits, we'll provide it as long as it's within reasonable amounts. Like if you ask for thousands of dollars, I think they'll be quite difficult for us to support. But we're trying to give you guys as much access as we can. So for example, coming back to this again, so you have access to not only the GPUs, but all the devices available. You can code in Qiskit, you can code in any language, and you can then kind of submit it through qBraid. PennyLane does have a few notions that are a little bit trickier, but if you use quantum tape, you can create your bell circuit here and submit it. You can check your conversion graph, make sure that it works on the conversion, and you can also just submit it, this circuit once it's in Qiskit as well. So that's the whole point, is we try to be as operable as possible with various functionality as well as functions that are available to you.
Okay,
Yeah.
great. Thank you so much.
So there you go. Now you get your Qiskit circuit now. So this is a Qiskit circuit object, which means that you can submit this to like a IBM device, or you can even use the same code that we had earlier to submit this to the SV1, for example. So you can just take this code, and that's how you could potentially submit your PennyLane circuit, for example. So I'm just going to convert this to Qiskit circuit. And I need to make sure that AWS SIM is executed. So let me make sure to do that. Boom, boom. All right, I got my devices. I got my AWS SIM, so I can just come here and just submit this job after I run this.
Greg, you just add QML to the end of Qiskit circuit, I think.
Okay, gotcha. Thanks. There you go. So now you can just submit it, and you'll find that this will run on your this SV1 simulator. I apologize for a few hiccups there. Should have been a tiny bit more prepared, but overall, you write your PennyLane circuits or Qiskit circuits, and as long as there's like a path here, it will do its best to convert it, and you'll be able to get your job results back. There you go. So I think that's kind of the beauty of qBraid here. You can write in various frameworks that you're interested in, and it's interoperable with them and the devices that you're interested on the backend. And this is the same thing. You can use this on Colab. You can use this on VS Code as well. You just need to pip install qBraid as well as its dependencies.
Okay, thank you, Rick.
Mhm.
To Alex. I think anyone have any questions more? Okay, I think we are good. Thank you for your clarification and for your presentation. It was very useful and helpful.
Mhm. Thank you as well.
Yeah, thank you guys. For any hiccups or troubleshooting during the hackathon, me and Harshit will be around to help make everything go smoothly. So thank you guys.
Yeah, thank you very much. Thank you. اوكي تمام، شكرا يا شباب. خلصنا كده السيشن دي، وان شاء الله السيشن الجايه في المونثلي سيريز الكوانتم اي اي لاب. هنستناكم ان شاء الله الساعه 7 كمان نص ساعه، فاللي حابب يستأذن او حاجه ويرجع تاني مفيش مشكله، اللينك شغال كده.
على نفس اللينك ده صح كده؟
تقريبا.
طيب زي الفل.
Okay, thank you, Ricky. Thank you, Alex. I think we are done here, and we are very welcoming you in Egypt, inshallah, in the hackathon, and we will meet you in Alexandria, I think. Yeah.
Thank you.
it's different.
شباب بقى ننقل على اللينك التاني بقى. اللينك ده خلاص كده موجودين هنا ولا ايه؟ ألو. عبد الرحمن، طاهر، رنا.
ايوه الجزء الثاني.
هننقل على اللينك التاني.